Hi, my name is Pranav K. Raju, and this is Physics Lab 5 Slinky. The purpose of this lab is to analyze the motion of a slinky using the tracker software, modeling the experiment using GlowScript, and comparing the experimental data with the model. In this experiment, the system is a slinky, and the surrounding is everything around it. Principles used. Through this lab, we are directly applying Newton's second law of motion, through which we get the position and velocity update formulas. Additionally, we are using gravitational force, which is the force that pulls objects with mass towards each other, and drag force, which is the force that resists the motion of an object. Here you can see is a preview of the two graphs we obtained after completing the experiment. The blue graph represents the data obtained through GlowScript, while the orange graph represents the data obtained by the tracker software. Procedure. First, using the tracker software, I track the position of the slinky frame by frame in an interval. Then, through the tracker software, the Y position and time are obtained and imported into an Excel file. Then, I created a computational model using GlowScript and obtained the Y versus time graph, which are then imported into Excel. And then, on Excel, I compared the tracker data with the computational model. Here's the marker motion using the tracker software, where I use a pre-recorded video of a slinky being dropped from a height. I set up the calibration stick and tracked the motion of the spring mass using the point mass tracker, and obtained the Y position over an interval. Here you can see is the code that was used to create the computational model for this experiment. In the code, we set the slinky's position and velocity and determined the Y position versus time in two different phases. First is when the top part of the slinky drops, and the second phase is when the whole slinky drops to the ground. And here is the output of the code shown in the previous slide. The blue graph represents the computational model from GlowScript, and the orange graph represents the tracker data. As you can see, there is a slight deviation after the first phase, and we will discuss this in the next slide. Sources of error. Point mass inaccuracies, as well as various other inaccuracies in the tracker software, and various external forces that are not taken into account when creating the model. What if, and what does it mean? What if we drop the slinky from a greater height? If we drop the slinky from a greater height, the time taken during phase 1 would remain the same. However, the time taken for phase 2 of the drop would be higher, as well as final velocity and displacement. What does it mean that the slinky's bottom stays still during the first part of the fall? It means that the force change caused by releasing the top travels down the slinky. Until this force change reaches the bottom, the tension there still balances the force of gravity, keeping the bottom in place. Thank you.